Okay, hi guys. So in this lecture, we'll be continuing on seeing some more interesting facts on carbene and the reaction of carbenes. Okay, so let's get started. So in the previous lecture, we saw only one method of the formation of or the preparation of carbene. In this way, in this lecture, we'll also be seeing another method to prepare carbenes. Suppose we have something like this: CH2NH2. I beg your pardon, CH2NH2. Okay, then if we heat it, we will get something like this is CH2. Okay, and N2. What actually happens is we already have something like this was the structure of CH2 and H2, which will be getting converted into again. This negative charge will form a bond between this nitrogen atom and this nitrogen atom, and as a result we'll be getting this will be again taken up by carbon atom, negative charge here. We'll get something like this. Okay, now what will happen is, on heating this compound, what will happen is N2 gas will evolve or release itself from the carbon compound, and as a result we will have the formation of carbene. Okay, with the evolution of N2 gas. Okay, so some points here, that carbene is easily formed in those reactions in which there is a reacting species. As in this case, the two nitrogens were reacting among itself or between themselves, so that they got themselves released from the carbon bond, and those were the reacting species in those reactions in which there is a reacting species. Okay, second point is carbene when uh, react with alkene or alkyne, formation of three member ring take place. So when carbenes when undergoes reaction with alkene or alkyne, formation of three member ring take place. Okay, now the next examples are, you have to prepare the carbenes and react carbene with cyclohexane. Okay, prepare carbenes and react them with cyclohexene. So we have something like this. H here, and we have tertiary butoxide. Okay, and this will actually attack on this hydrogen atom, and we'll get something like, and obviously this Br will be getting detached from this carbon atom, so finally we'll be getting something like 2Br and a dot. And when we react this with cyclohexene, what will happen? We'll have a three member ring formation. Okay, something like this. Okay, let's take a look at another example where we have Br, Cl and H. So which would be the better living group in among all of these? Obviously Br. Why? Because Br minus is more stable than F minus and Cl minus. Okay, that is the reason. So we'll get something like this F will attach with hydrogen atom. As a result, we'll be getting something like a negative charge here. In the second step, what will happen is this Br will actually take away the bond pair between itself and the carbon atom, and we'll get something like a carbene, which again on reaction with cyclohexene rather, will get this as the final product. Okay, let's look at another example. Here we have our COCHNO2 and we heat it. Again the nitrogen gas will evolve and we'll left with something like a carbene H here and C double bond O R here. Okay, what will happen in this case now? Again when we react this with cyclohexene, okay, formation of a 3-member ring will take place and we'll get something like this. I forgot this one in the last example. Okay, so we'll get something like this. Let's take another example where we have this ring. Okay, and N2 here. Again we heat it. What will happen is N2 will evolve and we'll get a carbene structure at this carbon atom and we'll get something like this. Okay, and we'll again react it with cyclohexene, we'll get something like this. Okay, now the last example for this lecture. So we have Cl and trichloro attached to this carbon atom and acid in presence of sodium Na, and we heat it. What will happen? We will get the oxygen will lose its H plus and will show the acidic nature and we'll get something like O negative and Na plus. Oh sorry, there's no bond, it's ionic. Okay, now next what will happen is this will form a bond pair with this carbon atom, and as a result the CO2 gas will evolve. Okay, and as a result we'll get something like a carbene again with the evolution of CO2 gas. Okay, so okay, I think there is a positive charge. The carbon atom will not take away the bond pairs, it will leave the bond pair for this carbon atom. As a result there will be negative charge here, and now till now there is no carbene formation, only CO2 gas is evolved and negative charge comes on this carbon atom. Now Cl minus will take away its bond pairs, resulting in carbene structure. Okay, so with this we come to end of this lecture and to the carbene preparation concepts and reaction concepts as well. From the next lecture we'll be seeing Riemann-Tiemann reaction. So till then, good luck and goodbye.